In this video, we are going to discuss the digital experiment, which is BCD to XS3 code converters and vice versa. The objective of this experiment is we are going to implement and verify the BCD to XS3 and vice versa using logic gates. And these are my team members. So, BCD to XS3 code converters and vice versa. The aim of the experiment is to design and implement BCD to XS3 code converters and vice versa using logic gates, and we are going to verify its truth table. The software required for this experiment is Multisim, and the components required are IC7408, which is AND gate, and we require 2 AND gates. IC7432, which is OR gate, and we require 1 OR gate. IC7486, which is XOR gate, and we require 1 XOR gate. IC7404, which is NOT gate, and we require 1 NOT gate. And 4 props and 4 keys are required, and the connecting wires are required as per our requirement. So let's recall the concept of BCD to XS3 and XS3 to BCD converters. Simply BCD to XS3 means the binary values gets incremented by the value of 3. So 0 plus 3 is 0 plus 3 is 3. While giving 0 as input, we are going to get the output as 3. While giving 5 as input, 0 1 0 1 and 0011, which is the binary value for 3, we are getting the output as 8. 1 plus 1 is 100 and carry 1, and 1 plus 1 is 100 carry 1, and 1 plus 1 is 100 and carry 1. 1 plus 0 is 1. While giving 3 as input, we are going to get the output as 6. 3 plus 3 is 6. And XS3 to BCD means the binary values gets decremented by the value of 3. So 0011, which is the binary value for 3, we are getting the output as 0. 3 minus 3 is 0. While giving 4 as input, 0100, we are getting the output as 1, which is 4 minus 3 is 1. This is the truth table for BCD to XS3 code. These are the BCD inputs, which are B0, B1, B2 and B3. These are XS3 outputs, which are E0, E1, E2 and E3. While we are giving BCD input as 0, 0, 0, 0, 0, we are getting the XS3 output as 3, which is 0, 0, 1, 1. While we are giving the BCD input as 2, 0, 0, 1, 0, we are getting the XS3 output as 0, 1, 0, 1, which is 5. While we are giving the BCD input as 6, 0, 1, 1, 0, we are getting the XS3 output as 1, 0, 0, 1, which is 9. While we are giving the BCD input as 8, 1, 0, 0, 0, we are getting the XS3 output as 1, 0, 1, 1, which is 11, and it is represented by B. After 9, the BCDs are considered as invalid states, so we are representing the XS3 outputs in don't care terms. We are representing these don't care terms in the K map in order to get the simplified expressions. This is the K map simplification for BCD to XS3 code, where E0 equal to B0 bar and E1 is B1 XOR B0 whole bar and E2 is B2 XOR B1 plus B0 and E3 is B3 plus B2 into B0 plus B1. Using this K-map simplification, we are implementing the logic diagram for BCD to XS3 code. And this is the truth table for XS3 to BCD code. The XS3 inputs, these are XS3 inputs and these are the BCD outputs, which are G0, G1, G2 and G3. While we are giving 3 as XS3 input, 0, 0, 1, 1, we are going to get the BCD output as 0. Simply access 3 to BCD means the BCD value, binary values gets decremented by the value of 3. So 3 minus 3 is 0. While we are giving the access 3 input as 5, 0 1 0 1, we are getting the BCD output as 0 0 1 0, which is 2. While we are giving the access 3 input as 8 1 0 0 0, we are getting the BCD output as 5 0 1 0 1. 8 minus 3 is 5. This is the K-map simplification for access 3 to BCD code, where B0 is E0 bar and B1 equal to E1 XOR E0 and B2 is E2 E1 bar plus E2 E0 bar plus E2 E1 E0 and B3 is E0 E1 plus E2 into E3. With the help of this K-map, we are implementing the logic diagram for access 3 to BCD code converters. This is the multisim implementation of BCD to XS3 code. These are the four inputs, which is B0, B1, B2 and B3. The inputs are in zeros and ones. We are representing these zeros and ones using the keys in multisim, and these keys are present in press, place, then components, then choose sources. In this, choose digital sources, then interactive digital constant. These are the keys, and then these are the four props, which is PB0, PB1, PB2 and PB3. Press place, then components, then choose indicators, props, and the various colors of props are available here. You can choose as per your requirement. And this is the hexadecimal display. We are using this hexadecimal display for our better understanding. These are the logic gates. This is 7432, which is OR gate, and 7408, which is AND gate, and 7486, which is XOR gate, and 7404, which is NOT gate. For the outputs, we are using four props, which is E0, E1, E2 and E3. And for our better understanding, another hexadecimal display is placed here. So let's simulate this experiment. When giving 0 as input, we get the output as 3. 0 plus 3 is 3. BCD to access 3 means the binary code gets incremented by the value of 3. So when we are giving 1 as input, we are getting 4 as output. 1 plus 3 is 4. And when we are giving 3 as input, we are getting the output as 6. 3 plus 3 is 6. While we are giving 4 as input, we are getting 7 as output. 4 plus 3 is 7. And when we are giving 5 as input, we are getting 8 as output, which is 5 plus 3 is 8. And while giving 6 as input, we are getting 9 as output. 6 plus 3 is 9. While giving 7 as input, we are getting 10 as output. 7 plus 3 is 10. While giving 8 as input, we are getting 11 11 as output. 8 plus 3 is 11 and 11 is represented by B. And the BCDs are valid up to 9. After 9, it is considered as invalid states and the outputs are represented in don't care terms. This is the multisim implementation for XS3 to BCD code converters. And the four inputs are E0, E1, E2 and E3. These are the XS3 inputs. And the four procs which is represented by PE0, PE1, PE2 and PE3. These are the logic gates and we are using the hexadecimal display in input as well as in output. These are the four BCD outputs which is B0, B1, B2 and B3. So let's simulate this experiment. While giving 3 as XS3 input, we are getting BCD output as 0. 3 minus 3 is 0. And while giving BCD, while giving XS3 input as 4, we are getting BCD output as 1, which is 4 minus 3 is 1. While giving XS3 input as 5, we are getting BCD output as 2. 5 minus 3 is 2. And while giving XS3 input as 6, we are getting BCD output as 3. 6 minus 3 is 3. We know that XS3 to BCD means the binary value gets decremented by the value of 3. So while giving 7 as XS3 input, we are getting 4 as BCD output. Now while giving 8 as XS3 input, we are getting 5 as BCD output. While giving 9 as XS3 input, we are getting 6 as BCD output, which is 9 minus 3 is 6. So the result of this experiment is we finally verified the BCD to XS3 code converter and XS3 to BCD code converters using multisim software. Thank you.